Good morning. My name is Brandon. I'm a aircraft maintenance supervisor, and for today's question, I wanted to go over the navigational system of a commercial airliner. I used to ask the question, how is an aircraft able to take off and land in really bad visibility to where they can't see where they're going? Maybe they're flying through some bad weather or lots of clouds and thunderstorms. Navigating around thunderstorms. So I kind of wanted to go over it from aircraft startup until landing and some of these systems that are used on the aircraft that enable them to make these flights very safely and reliably. So first thing, right as the aircraft is turned on, in the flight deck they have this system called an inertial reference system, or an inertial reference unit is what they're actually called. And so what this does is it uses the current location of the aircraft, which is usually the airport that it's sitting at, and it'll take the longitudinal and latitude numbers, which, as you know, that's just mapped out of the entire world and used for location. So it'll take those two numbers and then it'll compare those numbers to a GPS system that is installed on the aircraft. And all a GPS system is an antenna and a receiver and a transmitter, which works with 4 satellites. There's more satellites in the sky, but at all times there's always 4 satellites that send out radio waves, and the aircraft will pick up those radio waves. So the GPS in the inertial unit, that's essentially how the aircraft knows where it's at in space, in its location. So after that's set up by the pilots, the aircraft will load up. It'll get pushed back with a tug, and then either as they're being pushed back, or they may have already completed this as well. So there's a flight management computer and a flight, an FCC, which is a flight flight control computer. And so what the FMC does is that is the main computer that the aircraft uses for navigational data. The flight management computer also talks with the autopilot, which is in the flight deck. But the main point here is that the FMC, it mainly involves navigation and like flight paths that the aircraft is taking. And then you have the flight control computer, which the primary job of that computer is to actually move the flight control surfaces of the aircraft. That can change its lateral altitude, horizontal positioning while it's flying. And the autopilot will talk to both the flight management computer and the flight control computer. So the crew, they will have already inputted data into the flight management computer, such as the waypoints that they want the aircraft to fly, and these are generally based on pre-existing airways that all passenger airplanes fly. So they'll program this into the computer, and then essentially the flight management computer will fly the aircraft along those points using the flight control computer to actually change the direction or the altitude or lateral vertical movement of the aircraft. But you're at pushback. That's this information's been put into the system. The engines start up, they taxi down the taxiways. Essentially how airplanes move along taxiways is they're always identified as Alpha, Bravo, Charlie, Echo, letters like that. And the way it works is that the crew will call air traffic control, asking them or telling them that they are ready to depart and they need to taxi to a runway. And then the air traffic controllers will tell them how the route that they want them to take. Like an example of this would be, they'll tell the crew to go along taxiway Alpha to taxiway Charlie, stop before runway 20, and then generally they always have to stop before they cross runways. So then they'll stop before the runway, and then they'll call back to the tower, and then they'll allow them to cross the runway. But air traffic control will direct them exactly to which runway that they want them to depart from. And another thing is that the runways are actually, they're ID'd based off the direction that they're pointing on a compass scale. So example would be runway 0 would be pointing to the 0 degree mark on a compass. So after they get ready for takeoff, they're lined up on the runway, they go full throttle. And so some aircraft have a system which is part of their autopilot system called an auto throttle, and so that'll be already set. So all the crew has to do is push a button on their flight director, and then it'll automatically give the aircraft thrust to take off. And then all the pilot really needs to do is just have their hand on the throttles. Not all aircraft do this. Some have auto throttle, some the crew has to actually manually forward the throttles to whatever the predetermined thrust setting is that is also inputted into the flight management computer. And then essentially once they get the throttle, the crew is going to call out their different V speeds. If I remember correctly, the first speed is going to be if they lose like one engine, for example, they can still stop the aircraft. And then the V2 speed is you can still continue on one engine. And then the VR speed is once you get up to that speed, they can no longer safely stop on the runway. And I could be slightly wrong with those V speeds, but that's essentially how they're set up to be, so that if you lose one engine, you can continue the takeoff roll. And the primary method that aircraft use for long distance navigation is going to be the GPS. And like I was mentioning earlier, the GPS works off 4 satellites, which is in constant communication with the aircraft radio receivers. So essentially, based off the 4 signals the aircraft receives, it's able to use a GPS computer to triangulate exactly in space where the aircraft is. And then the GPS talks to the flight management system, and the IRUs also talk to the flight management system to let the computer know exactly where in space the aircraft is at all times. And then depending on where their waypoints are set and what altitude the air traffic control wants them to fly to, which is generally the first couple minutes after takeoff, they'll listen to the air traffic control, and they will tell them which altitude they want them to fly to. But then once they get out of the close airspace to the airport, they will go by their flight plan to their final cruising altitude. And then all throughout cruise altitude, it's most of the data is based off GPS for, like I said, long distance travel. And then after flying along, and when you're getting closer to your airport you're going to land at, they will start their descent. And that's all still based off waypoints, which I believe they're called vectors, which is based off pre-existing data and common use airways of where you're flying. But as you get through the descent and you're coming in for the 3 ways the ILS works, of the systems that it uses, is the localizer, the glide slope, and marker beacons. And so to make it simply, is so every airport is set up with a radio stations, and these radios, the way airplanes know where they're flying is based off radio waves shooting out of the airport and then the aircraft picking up these radio waves and then using them to determine their lateral, vertical place in the sky when they're coming in for a landing. And so the glide slope is going to be the vertical sinking of the aircraft, and it's set up to where it has a set slope it wants to fly down. And the glide slope, the radio waves that receives will tell the aircraft and the crew flying it if that aircraft is on the right slope coming down for landing, using radio waves that the airport sends out and the aircraft receives. And it's the same thing with the localizer. There's localizer stations at the airport that send out radio waves that the aircraft will pick up, and then it compares two different radio waves together to tell the pilot and aircraft if laterally, if it's on the correct, if it's lined up with the runway correctly. So using those radio waves, it can tell the aircraft laterally and vertically if it's on the correct pathway. And then the aircraft will use the flight management controller and the flight the FCC, the flight control computer. It'll use these two computers and the radio waves and the receivers to change how it's flying to make sure it's lined up properly with those three systems, or two systems. The third one was the marker beacons. And so marker beacons at every airport as well, there's marker beacons that are set out at different lengths away from the landing, wherever the landing strips are. So I think they're usually like 5 miles and then 10 miles or so. And so there's also another computer on the aircraft that picks up those stations so that the airplane knows how far away it is, the slope it's gliding down, and if it's lined up on the runway. And then so it'll take readings from all of those different systems and input them into the flight management computer, which will also talk to the autopilot and the flight control computer to ensure the airplane is lined up how it should be when you're coming in for landing. And then as far as like redundancy for those systems go, each flight management computer and each flight control computer have 2 to 3 different channels that if one channel fails, the other channel will automatically pick it up, and there'll be nothing the crew has to do. Just one can fail on final landing and seamlessly the aircraft will pick it up. Same thing for both systems. Another redundancy is also, in addition to those ground systems that use the ground and radio waves, there's also GPS that will, the data that the airplane's picking up from the ground radio systems, it'll compare that data to the GPS receiver that it's receiving from the 4 satellites I was mentioning earlier, because that also has the airplane triangulated in space, and there's predetermined GPS routes based off like what your vertical and lateral, like what those numbers should be. And then so the ground systems that the airplane is using will compare those to the GPS. So you can even, the only thing with GPS is it doesn't work as good when you have like terrain and stuff in the way, but some airports are set up for GPS, and all of those systems will talk to each other. So if you did lose one, you can still reliably land. And yeah, so and then let's say something happens, like you're coming in for landing and you have a autopilot failure, or maybe you lose a signal, or you're coming in with too much vertical speed, or somehow you drift out of your lateral positioning. There's the crew will do something called a go around, which is they will abort the landing and give it full throttle and fly around and come back in for another landing to ensure everything is lined up properly. But generally, most of the time, everything goes good, and they come in for their landing. They land, they roll out, they taxi the same way I mentioned earlier, back to the gate. Turn the APU on, hook up. They'll usually run the APU and turn off one of their engines and taxi to a gate. Unload all the passengers and reboard and do the same thing again. And that's really it. Thanks for listening.